Hey, hi. In this video, I'm going to show you how to deploy Python Flask web app to AWS Elastic Beanstalk with using GitHub Actions. As you see in this PPT or in this screen, this is PPT depicts my demo. Here, I'm going to show you by using this diagram, I'm going to show you how we can create and deploy AWS Elastic Beanstalk, which is actually hosting Python web application, right, with using GitHub Actions. All right. So before I walk you through the two steps of my demo, a kind request, please do subscribe my channel. That would really encourage me a lot. So with that note, let's directly jump to this demo here. In first part, I'm going to take you to the through the how does this design works. In the second part, I'm going to walk you through the code, and finally I'm going to show you how does this deployment works. And finally we see fully fledged web app being running on Elastic Beanstalk. Yeah. So as you know, Elastic Beanstalk is a service from AWS where you can deploy your web application or any kind of other applications on this one. Yeah. So all right. So now let me first walk you through this design diagram. Yeah. So here I'm gonna show you from end to end. So here, we're gonna write a Terraform code which actually manages the infrastructure at AWS with using infrastructure as a code. And we do a CI/CD job with using GitHub Actions. And finally, we see that these two workflows are actually creates a AWS Elastic Beanstalk application and environment in the AWS account. And finally, we see that our application is up and running fine. Yeah, this is like a completely end to end. Okay. So let's say you have a developer who is actually working on the two things here. Okay. So one is actually developing the Python web application that is with using the Flask framework. Yeah. And once that image or once that application is been built, you will wrap it as a kind of a package, say in the form of GIF file, which can be used by the web application hosting service, that is Elastic Beanstalk. Yeah. So in that case, he would be doing two jobs. This developer will be doing two jobs. One is he will be going to write the Terraform code, which is meant for infrastructure as a code, and he also going to have a Python Flask web app being written and zipped, which is easy to deploy at the Elastic Beanstalk. Yeah. And once the code is been committed, let's say we will write a Terraform code and also the Python Flask web app such a way that it will spin up the infrastructure and also does the deployment of the web application onto that infrastructure. Yeah. So here we are using the CI/CD tool from the GitHub, that is GitHub Actions, which actually pushes the web app to the Elastic Beanstalk. Okay. So the steps are, as a developer commits the code to the GitHub, we have a workflow being defined, that is GitHub Action workflow being defined. The GitHub Action workflow will be invoked by using the GitHub Actions, which actually spins up the infrastructure called Elastic Beanstalk on AWS. And once the environment and apps been set in the AWS account, you can use the URL or the endpoint of your application and browse your web application, which is working fine, right? So that is where the step number 4 tells all about. Yeah. And finally, you see, right, there is a screenshot being attached here. This is what we're gonna see it. Okay. All right. So this is all about the the workflow define. This is all about explaining my workflow here. So before I walk you through this one, I will just let me take you back to my GitHub Actions, my GitHub repository. This is my GitHub repository. I have a GitHub repo called GitHub Reusable Workflow. So this, I have made a very dedicated video on how to build, construct, and use GitHub Reusable Workflows. You can watch how to set up this in regards to this one in my another video. Maybe you can go and have a look at how you can set up the reusable workflow from on GitHub Actions. Okay. So I'm using the capability of reusable workflow at GitHub, and I have created a workflow called Elastic Beanstalk web app. Yeah. And this is the workflow which actually creates the infrastructure and also hosts the application on Elastic Beanstalk. Okay. So what I do is I'm gonna step ahead, step 4-5 minutes ahead, and just trigger this workflow. I'm gonna connect these dots later. So if you can follow my video, you will understand why I'm doing this early. Yeah. So what I do is I'm gonna invoke this workflow by manually because I have defined my workflow to be invoked by workflow dispatch, and that's the reason the infrastructure is being created right now. You see here So this is being you see, this is being ignored because I am targeting to a main branch, but instead that I have to target to a develop branch. So if I go back to my workflow, so here it says it should be pointed to a develop branch, yeah, then only it will be deployed, yeah. So if I choose the branch develop, I'm going to explain all these right now, don't get confused basically. So that's the reason I said I'm going a 5 step ahead, and doing these invocation first, because this is going to take us some time. And meantime I'm gonna walk you through the code as well. Okay, so let's see, this is being built. Okay, this GitHub action pipeline is running. Okay, and this is the source of truth that I'm showing you end to end. Yeah, all right. So while it is running, and I will come back to this stage, let's go back to the infrastructure as a code. Okay, so the first phase is I have walked you through this design. Now I'm going to walk you through the infrastructure as a code, and also the the zip file, that is a Python Flask web app, the source code being wrapped as a zip file. Okay, all right, so here I'm going to walk you through the code as well quickly. So this is my GitHub repo, which I was showing you earlier. So in this repository, the repository name is GitHub reusable workflow. I'm going to share the links of this repository in my video's description. You can find these files from there. So in this workflow, I have created a workflow name called elastic beanstalk.yaml file, which is a reusable workflow. Basically, this is the master, or the caller file, the caller workflow file. And the other two, that is a Terraform apply and Terraform plan, are called as a called files of the workflows. Yeah. So we will connect this, we will see how does that connects. Yeah. If you want to, very interested, and if you want to know how these are being connected each other, please do watch my another video called reusable GitHub workflows, which I have created dedicatedly for this purpose to help you to understand. Yeah. For now, let's look at the Elastic Beanstalk. Yeah. So right now I have created a folder called Elastic Beanstalk. So in that folder, it has a dev.tf file, a file called elastic beanstalk.tf file, a zip file, that is Flask app file. Basically, it's just a very plain and straightforward Flask app been written. I'm going to show that code in just a while ago. And it also contains a main.tf file and the variable.tf file. Yeah. So before I walk you through these files, so let me go from the bottom actually. Yeah. So as you see, this repository, in this repository, I have created a dedicated folder called Elastic Beanstalk, which is meant to manage my Elastic Beanstalk infrastructure. Not only that, it also means to host the application onto that Elastic Beanstalk. Okay, so basically I'm doing the two job with using Terraform, right? So here in the Terraform variables.tf file, we have defined two environmental variables, two variables basically, and those variables are type equal to string, that is environment and the project. Yeah. And then if I go to the next file, that is in the main.tf file, so this is the file which actually defines the backend of my Terraform infrastructure, of my Terraform invocations. Okay, so whenever you do a Terraform invocation, you should have some backup, you should have some backend. So backend is nothing but is a place where actually the Terraform keeps the state of your infrastructure. Yeah. So in this one, I have the flower bracket. I have a variable called Terraform, and it has a certain parameters within it in the flower brackets. Okay, which includes the required providers. In that one, AWS. So I'm using the HashiCorp AWS. And the backend, this is a very special one, so you need to understand, every Terraform has a backend. That's what I said, right? So here my backend is remote, right? So which is nothing but TFC, that is a Terraform cloud. Yeah. So that's the reason host name is been given as app.terraform.io. This is the syntax that you need to follow. In that one, I have an org called cloudquicklabs, which is my channel name. And in that one, I have created a workspace called Elastic Beanstalk. Okay, so if I go to the TFC, I have created a TFC environment. So this is my TFC subscription. Okay, if I go to the workspace back, yeah, so in this one workspace, I have the couple of workspace. So in this one, I will go to the Elastic Beanstalk. So this is the workspace which is actually I'm using. Yeah. And if you want to know more about the how to subscribe to a Terraform cloud and use the free workspaces and free organizations being given from the HashiCorp, you can do so, and you can watch my another videos where I have explained around these one. Okay, as I was triggered and as I was invoking the GitHub action in the last a minute back, so that is being running. Okay, so ignore this for now. All right, and that is what this workspace is all about. Now we'll go to the next file, that is Elastic Beanstalk. Okay, this is the file which actually does the magic at AWS and creates your infrastructure called Elastic Beanstalk. and actually helps you to host your application on the Elastic Beanstalk. Okay. All right, I will quickly walk you through this file as well. Okay, so in this file, we are creating couple of resources. The first one is the S3 bucket. So we are creating an S3 bucket called EBS Python Flask 001. This should be globally unique name. Remember that, yeah. And then I will go to the next one. So in this bucket, which actually I'm keeping a flask.zip file. Okay, so that flask.zip file is this is the file. So basically this is a package of my Flask application. I'm going to show you a minute after this one, saying like what this Flask app.zip file contains. Yeah. All right. So and in this one, so here what we are doing is we have created a bucket, and in that bucket we are creating this. We are keeping an object with a key name called flask_app.zip file. Yeah. All right, then I will move next. So in this, we done with the two resources. Now we are going to create one more resources called AWS Elastic Beanstalk applications. Okay, so when you say Elastic Beanstalk application, it needs two things. One is you need to have a environment, you need to have an application. Yeah, these are the two important resource types that falls under Elastic Beanstalk. Okay, so for this case, I'm creating a Elastic Beanstalk application first. This is the name of my Elastic Beanstalk application. For now I have just kept it very simple, yeah. And this is the description though. And then after that we have the Elastic AWS Elastic Beanstalk application version. So as I said, every time whenever you do a deployment to that your Elastic Beanstalk, it maintains the versions of your application, right? And this is the resource which actually been created on top of the Elastic Beanstalk application, which maintains the versions of your application, right? So, and in this one resource type, what are the parameters that I'm passing? So here you can see, right, I'm giving a parameter with the name of the bucket name, and what is the key within that bucket, right? And what is my application name? So that is being referenced from the above resources, and the name of the version as well, yeah. All right, and the next one is the final resource that we are going to create. So basically in total we are creating how many? We are creating 5 resources. As I said, there are 2 resources, important resources, right? One is the Elastic Beanstalk application, and then Elastic Beanstalk environment. So this one is the resource which actually creates an environment where actually your application goes and gets hosted, yeah. And here we definitely need to give an environment name. This is my environment name. You can say like say Flask app development, Flask app production, Flask app UAT. This is where you can declare the environments of your applications, right? And then in the application, you can give your Elastic Beanstalk application that you pointed or created above. And this is very important, few more properties, that is which kind of hosting environment you need for your application, right? So to run our application you need some environment, that is runtime environment, right? So that is the solution stack name tells all about, right? So here is a 64-bit Amazon Linux. So this is the virtual machine, or you can call it as a EC2 instance, which gets spinned up with a runtime called 3.8, and then that becomes that virtual machine, or that EC2 instance becomes a hosting environment for your application, yeah. And this is a description and the version label. So this is the way the version labels are being given. And in the settings, okay, in the settings, basically in the settings, I'm just we are keeping certain configuration, that is auto scaling, large configurations, keeping very default configurations, okay. Since this is just like a to help you to get started with using the Elastic Beanstalk, with using Terraform, with using the CI/CD, that is using the GitHub Actions. So this video is meant for to help you with it, yeah. Anyways, one more bonus point for you, that this environmental, you can also by default, whatever the resources we are creating here, by default it uses the default VPCs, subnets, right, and the route tables, network security groups. So it uses the default resources which is needed for the hosting. So that's the reason it is important for you to maintain a default VPC, and the default resources related to that VPC should be there in your account, then only it will work, yeah. Or else this solution may not be, would be failing, yeah. And also at the production level, I would suggest you to maintain your own VPC, maintain the VPC related resources, and host your Elastic Beanstalk environment related to that environment. So here, so if you are using your own VPC, maybe the properties of this environment would change accordingly, yeah. All right, that is a very important hint here. Now let's go to the dev.tfr files. So here in the dev.tfr files, if you see here, we are giving the environment equal to prod because just a demo purpose, and the project name is this one, yeah. All right, so and I think one more thing I didn't tell you is, in the provider. So here I have an AWS account, okay, and the AWS account related configurations are being maintained on my on this workspace. I'm going to show you that as well. And here, we are pointing to the AP South1 region. Okay, that's a very, very important one. Now let me go to the TFC first. Looks like, the run has happened successfully. I will go to the Elastic Beanstalk. Yeah, and if you go to the variables, in the variables, I have set the workspace variables of type category environment. Here I have kept the AWS access key and access secret. So you need to create two keys with these name, okay, and case sensitive. Remember, you just need to create a keys with this name, and the value of your IAM user can be kept it here. And with these configurations, the GitHub Actions, with these configurations, the GitHub Actions, basically, whenever GitHub Actions runs, it uses these. Whenever the GitHub Actions invokes the TFC workspaces uses these environmental permissions and executes the command against your AWS account. Yeah, that's what it happens underneath. Yeah. All right, so I think we are done with it. This is what I'm done with the code walkthrough. Now let's see the real time, how does it deployment happen. Yeah, and this code is being merged to my GitHub, upstream GitHub repository. This is my upstream GitHub repository. And let me switch back to the development environment here. And in this development, this is our folder structure. This is where actually our applications is been application related Terraform and the zip file is been hosted. And once we run this GitHub Actions, which is manually invoked, this is the GitHub Action workflow which is relevant to this deployment. If I open this one, you see it has a 2 steps basically. Yeah. So I need to explain you one more thing. So basically I need to so while I explaining this one, yeah, let me step back to the code again. So don't get confused, be patient. So here in the workflow, so what I'm doing is I'm going to walk you through that, what did I do in the workflows. Okay, so how did I define my workflows? Anyways, if you are following or if you are watching my reusable GitHub workflow file, you're going to get the details about these, how I have set it in more depth. For now, I'll just make you a quick walkthrough. So this is, as I said, this is called as a caller file. In this caller file, I'm calling a file called tfplan.yaml file and AWS tfplan.yaml file, which is sitting in the same GitHub workflows. If you see here, and the branch is developed here, and we are this job gets invoked whenever there is something happens on the branch develop with a parameter like path, the tfr file name and the dev name will be passed. Okay, so this stage actually runs the plan and this stage actually runs the Terraform apply. Yeah, and if you go through these files, yeah, so you will understand what is actually basically in the tf apply and the tf plan, I'm just running a respective commands, that is the Terraform plan and Terraform apply would be running here, right? So now let me take you back here. So as you see here, there's a plan dev and there is a deploy dev. Okay, so where is the names are coming from here, right? So those names are been coming from here from the reusable called file. So this is a plan dev and this is a deploy dev. Yeah, so as the name says, plan is for meaning the plan and deploy is mean for deploy. Yeah, so if I open the plan first, so in the plan actually I have the we have actually executing the the all the Terraform plan and it actually creates a draft here. So if I can open the logs of my Terraform plan, and if I extend this one, it actually gives a draft of the what is the thing that I'm going to execute here. It says that that it has to create a 5 resources and 0 destroy and 0 changes. Yeah, and then finally goes to the next stage where actually we are actually doing a Terraform apply. So in the Terraform apply, as you see here, it has actually created the required resources, which we thought like 5 resources and which is needed for our hosting purpose. So that's resources are being created. All right, and the same thing gets replicated here in the workspace, that is a Terraform cloud. So if you can see the details here as well, if you go to the Terraform cloud. Okay, all right, so this is all about setting your GitHub, connecting using your GitHub Actions and doing a deployment to the AWS Elastic Beanstalk. Yeah, and once this has been done, if you go to your AWS account, so if you go to your AWS account, refresh it, you should be seeing an application up and running fine, right? So currently I'm in Elastic Beanstalk AWS service page, and I'm in Mumbai region. So if you go here, so I'm in the Mumbai region here, that is AP South one, and our application with the name ENBSB is been created here, right? And if I go to the environment, so if you see here, so there is an environment bin underneath here. If I select this one, here you go, your application is up and running fine, right? You see the health is okay and the deployment is happened done, right? And all right, so now you are set to browse your application. So there is an URL here. If you click on this URL, you will be seeing your application been running fine, right? So you see the Flask application is been running fine as expected, and that is what I have walked you through this one, right? All right, so finally, before I conclude this call, I'm going to show you, like, what did I keep in the zip file for this demo, right? So I'm going to go to this one. This is my systems GitHub repository, that is a local repository, and I'm going to go to the Elastic Beanstalk, and if I go to the Python Flask, so this is what it contains. Okay, basically it's just a Flask app definition. So if I open this in a Notepad++, so open it, maybe it is executing, so I need to open it in a so basically how can I open it? This one, so basically, so it contains ABC extensions, nothing but it's just just like a Flask application, right? It contains the requirements, and this one, properties, or just say, so since it is a zip file, I cannot open it. Maybe I'm going to share this app in my GitHub repo, and the GitHub repo link can be found in this videos description. All right, so with that note, I have successfully shown you the things need to be shown in this video from scratch to end, like how you can wrap your web application, for example Python web application, and how you can use the Terraform code for maintaining your infrastructure as a code, how to use the GitHub Actions to achieve your CI/CD solutions for your web application deployments, and how to wrap your application as a zip file and use it in a Terraform to deploy your application on Elastic Beanstalk. And finally, we also saw that your application is up and running fine. All right, so with that note, I have successfully shown you the things need to be shown in this video. Finally, thank you very much, and see you in the next video.